Hey, Greg Griffiths here, and I've got a version of the Raspberry Pi Doorbell. A lot of people out there on the web have Raspberry Pi doorbells, but what I've done differently than them is actually put a proper electrical circuit to detect the audio analog waveform sine wave from the speaker from the doorbell. So here's the doorbell. You can see I've got clip leads on the speaker terminals going to the circuit here and then to the Raspberry Pi. There's a Wi-Fi dongle and a camera on the Pi. And so we'll run the program here, and when the program runs you can see the light on the camera comes on, and then we press the doorbell button. You can see the LED blinking there, which indicates an open collector transistor circuit. And we just got a new email, picture of visitor at the door, and that's a picture of the top of my garage. So if you'd like to see more details about the electrical circuit, you can go to GitHub/Griffegg, Griffegg, /doorbell. And basically what you have is the speaker signal, which is really pretty low voltage, less than a half a volt, maybe a little higher, but definitely under 1 volt, coming into a diode which rectifies it, clips all the negative signals, so you only have a positive analog signal coming in. That goes to a resistor and then charges a capacitor. So you have a DC voltage charging into the capacitor every time the doorbell rings, for every tone the doorbell makes. And it makes about 5 tones, right? So those 5 tones charged up that capacitor, which is now enough voltage to turn on a transistor. And you can see the transistor right here. So the transistor turns on, and when it does, it connects the circuit to ground, and so the LED turns on. So the resistor is positive voltage to the LED to the transistor collector, and when the transistor turns on, the LED lights, and it gives a falling edge signal to the Raspberry Pi GPIO 23 there, you can see with a blue wire, and that causes an interrupt to the Raspberry Pi, which then goes ahead and takes the picture.